So what is happening when we are starting designing all these plans and start making all the calculation for quotation and projects and so on? We find out always the same. We have this standard system. We have all this calculation that is based on static scenarios where the electricity prices remains constant, the payment from production is the same, and the recovery rate is also the same. So we have, let's say, a real ideal scenario, but that's not the real life. And with this scenario, we are comparing two different technologies. That's fair? Probably not, or not at least fair for us. So in this presentation, I will show you how it looks like the different, or the real different in real life. So, as I said, the world is not static. We have a different membrane pressure through the years. It's quite obvious that through the year you have more temperature, more salinity. This will change during the year, and obviously the pressure will be affected. About water demand variations, again, let's imagine here in summer sake how it looks like the water demand. Obviously, maybe during summertime they need more water than the winter time because there's more people in the hotels and so on. So you need to produce more water. So electricity price, another variable, and all these will affect the power consumption of the plant. This is just a combination of renewable energy like solar. What is happening when we are taking this energy from solar panels, and it's obvious that in the center time of the day we are producing more energy. But this is just when the demand is low. So we are not, let's say, able to get all this energy from the grid. And we should start producing more water to stabilize the grid. This is just an example of how it looks like a water demand on a site. So the idea is try to optimize as much as possible all this water production and produce more water with less consumption or with less electricity cost possible. So have in mind these two different ideas. We consider two different scenarios. The first one, the one that I talk about, this static scenario where everything remains constant, like the electricity price, pressure constant, is the electricity cost is also the same. And obviously, this is the ideal scenario that never happens. And what happened in the second scenario, we believe, is the real life. We have different variables. We talk about this seawater pressure variation. We have this salinity and temperature of seawater that will change through the year. Also, these electricity prices is obvious that probably depending on the night is less expensive. So, I mean, we need to take advantage of all these things in real life. And again, water demand is another variable that we need to take into account, and we need all these three variables we need to take into account to optimize or try to optimize as much as possible the power consumption of the plant. Because at the end is what we are looking for, right? We try to optimize the system, the applications, the product, but we need to do it in the smart way possible. So if we compare both the scenarios, this is the end of the presentation. So basically we have different savings and different consumptions. You will see in the first scenario, we have really good savings from 500 CMD plants to 10,000 CMD plants. So we are talking between 7% to 21%. But the real life is that we are having even more. We have 26% saving in the best case possible. So we need to somehow take advantage of all these variables: electricity price, water demand, and pressure variation that we have all the year. So all in all, we can say that the savings that we can get from one real life and the static world that is not the real one is really, really different. And if you think about a 25 years lifetime, that is basically we are talking again and again in all the projects. In a 50,000 CMD plant, we are saving 14 million euros. So it's a lot of money. We can do all the maintenance that is needed, all the refurbishment that is needed, and everything. So take in mind that it's a lot of money that so many times we don't think about. So conclusion, it's obvious that we are looking for carbon neutral, and the only way to achieve that is try to optimize as much as possible the systems, the technology, all the applications. We saw during these webinars and all these presentations how all these application and system is changing to try to adapt the real conditions. And obviously, in our case, from Danfoss, that we are developing and we are manufacturing the pumps, obviously we are making the effort of trying to develop and manufacturing the highest efficiency in the market, so we are helping also to reduce this carbon footprint in the market. And yeah, some other things, some practical benefits. I mean, we are running with low voltage model, low voltage equipment, so it's also helping in the way that lower the capex, but also helping you for the maintenance replacement. It's much easier, much faster, so we can face in a better way all the production water demand problems that we can have during